Hi all, and welcome to your last lesson of quarter 3. As probably all of you know, spring break is next week, which means that this week is the end of quarter 3. If you have questions about some of the assignments, maybe how you want to improve your grade, if you want to resubmit anything or submit corrections, please look into that. You're going to have some time tomorrow to work on missing and incomplete assignments. And if you have questions about any of those assignments that you want to work on, please don't hesitate to reach out in comments, email, or setting up a Zoom. Let's get started on our one new idea for this week. So find this page in your notes packet, get yourself ready to go. So what these questions are going to be about in 10.3 is solving equations with variables on both sides of the equation. So something like 3x minus 7 is equal to 5x plus 11. So we have an x term on one, x term on the other. Now, our goal for all of these is we want to get something that looks like x by itself. So that means we want to cancel out the variable from one side. And that's just fine. We know how to cancel them out. Usually this is just going to be a subtraction problem. Might also be an addition. So you're like, oh man, I wish there wasn't an x term, over here. So you can either choose to subtract away 3x, which will cancel it out here, or subtract 5x, which will cancel it out here. I'm going to choose to subtract 3x just because that's going to make one less negative term. So because 5x minus 3x is 2x. Cancels out on the left side, so I'm left with negative 7. And then I still have my plus 11 here because my like terms, 5x minus 3x, go together. From here, we can just solve like normal, which means that I'm going to subtract 11 from both sides. Now we just want to make sure we're practicing with negatives. Negative 7 minus 11 is going to be even farther negative, so it's going to be negative 18 is equal to 2x, since the 11 cancels out here. When we divide by 2 on both sides, negative divided by a positive is a negative, 9, 18 over 2, and we get x by itself, so our final answer is x equals negative 9. Now here, we have a problem with fractions. Now, you can still use the same basic idea. You can still use common denominator. You can still use like terms. You can still use distribution. The techniques are always going to be the same. You're just going to have, at one point, going to have to subtract or add from both sides. So in this case, I see fractions, so I'm going to use a common denominator. I see that my denominators here are 2 and 3. So I'm going to make my common denominator 6. So in this case, I'm going to multiply this fraction by 3. So my denominator is 6. This fraction by 2, by 2, by 3. So I'm going to get the denominators. I'm going to get 9z over 6 minus 17 times 2 is 34 over 6 equals 4z over 6 minus 9 over 6. Now when I multiply everything by 6 on both sides, all the denominators cancel out, and I'm left with 9z minus 34 is equal to 4z minus 9. What I'll notice here is that I have a variable on both sides, so I'll just pick one to subtract. Like I did before, I'm going to pick the smaller one so I don't have more negatives than I have to. So great, now I only have the z terms on this one side. 9z minus 4z is 5z minus 34 equals, not plus, equals negative 9. From there, we can solve like usual. I'm going to add 34 to both sides. Negative 34 plus 34 cancels out. So I'm left with 5z is equal to negative 9 plus 34. Sometimes it's easier to just say that's 34 minus 9. Notice the positives and the negatives are staying the same. Negative 9 minus 9 positive 34, positive 34. And 34 minus 9, or negative 9 plus 34, is 25. Divide both sides by 5, and we get z is equal to positive 5. If you have questions about any of the equations or any of the assignments you want to make up going into your spring break, please be in touch.